Geometry World. What we're going to work on today is 5.2 perpendicular and angle bisectors. So let's make sure we know what all of these vocab words mean. Perpendicular means two lines intersect to form right angles. And bisector means that two segments intersect so that one segment is cut into two equal congruent segments. So in this picture we have line PM is perpendicular to segment AB, and the length of MA equals the length of MB. So that means M is our midpoint. So line PM bisects segment AB. So that's what we have here, is a perpendicular and a bisector at the same time. Well, we have a theorem about this, and it says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what that means is if I pick any point on this line, any point on PM, so if I take point P, and I want to create a segment so that P goes to endpoint A and P goes to endpoint B, those black segments that I just drew are going to be congruent. And here's why. Go back to what we did last chapter with congruent triangles. I know I can mark segment PM congruent to segment PM because that's my reflexive property of congruence, which means I've just created two congruent triangles. Triangle PMB is congruent to triangle PMA using side angle side. So since those two triangles are congruent, I know all of their corresponding parts are congruent, which means that PA is congruent to segment PB, so they have equal lengths, meaning P is equidistant to both of my endpoints. Well, this theorem also has a good old converse, and a converse, if you remember, switches your hypothesis and your conclusion. So this one starts with if segment PA is congruent to segment PB. Basically, if you start with an isosceles triangle, then you know if you make a perpendicular bisector in that isosceles triangle. Okay, so let's look at one. For here, we want to know what is the length of segment AB. And we know that BD is a perpendicular bisector of segment AC because we're given our little tick marks here. Segment AD is congruent to segment CD, and we're also given our right angle box to show that it's perpendicular, which means that B is equidistant from A and C by your perpendicular bisector theorem. So if we use our perpendicular bisector theorem, we know that the length of BA equals the length of BC. So let's substitute in. We have 4x equals 6x minus 10. So to solve this, we need to subtract 6x from each side, and you get negative 2x equals negative 10. Divide both sides by negative 2, and you get x equals 5. So now we need to find the length of AB. So we'll substitute back in. For AB equals 4x, we're going to substitute in our 5. 4 times 5, we can simplify this and know that the length of AB is 20. Awesome. Here's another perpendicular bisector question. A park director wants to build a t-shirt stand equidistant from the rolling coaster and the spaceship chute. What are the possible locations for this stand? And explain this. All right, so here's our plan. How do you find a point that is equidistant from two given points? Well, by the converse of your perpendicular bisector theorem, a point equidistant from two given points is on the perpendicular bisector of the segment that joins those 2 points. So, I'm going to make my segment that connects my rolling coaster to my spaceship chute. And from there, as long as I can find my perpendicular bisector, I know anything equidistant has to be on line L. So if I pick any point on line L, that's going to be a great place for my t-shirt stand because it's going to be the same distance to the rolling coaster as it is to the I have a trouble with that. Spaceship chute. There we go. Alright, So those are perpendicular bisectors. So next up, let's look at an angle bisector. So bisector again means you're going to cut it into two congruent parts. So we're going to take our angle and split our angle up into two congruent parts. So we have angle PQR. And you see how ray QS bisects angle PQR? And we have two congruent angles right here. Angle PQS is congruent to angle RQS. Well, when that happens, that ends up making, again, two congruent triangles. The key thing here is that these guys must be right angles. SP, segment SP, has to be perpendicular to segment QP, and segment SR has to be perpendicular to ray QR. As long as you have that, and we can go back in and mark our reflexive congruent side, our two triangles are congruent with angle, angle, side. So as long as our two triangles are congruent, it means all of our corresponding parts are congruent, which means segment SP is congruent to segment SR, so those have the same length. So here it is in words. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So that's the key thing to know, is that any point on here, so if I pick another point, and as long as I go perpendicular, then I know those segments are congruent. And again, it has to be the perpendicular ones. Any point, as long as it makes perpendicular, will be equidistant. Okay? This also has, again, another converse. So let's switch it up. If you have a lovely picture like this where you've got your perpendiculars and you know that PS is congruent to RS, then you know you have that angle bisector in there. Even though it's not drawn in, it still exists. So there's your converse. So let's look at an example. What is the length of segment RM? Well, here's segment RM here. Well, do you see how angle N is bisected with these little arcs here? And we know that it's perpendicular, that RM is perpendicular to LN, and segment RP is perpendicular to segment NQ. So we know we have an angle bisector. So we're going to use our angle bisector theorem that says segment RM is equal to the length of segment RP. So if we substitute in, we get 7x equals 2x plus 25. Subtract 2x from both sides and you get 5x equals 25. Divide each side by 5 and you get x equals 5. So let's use that now to find the length of RM. So RM equals 7x. So if I substitute in for 5, 7 times 5, I know the length of RM equals 35. So I hope this helps with your angle bisectors and your perpendicular bisectors.